Today's video is about the inorganic chemistry, the group trend. I'd first like to explain you that what a group trend is. A group means we are talking about the periodic table and the elements that are located in the group. A trend is the regular behavior or regularity. If we relate it to the elements, it means that it will be the regular variation in the properties of elements in a group of the periodic table. If the behavior is regular, that is a group trend, but if there is any irregularity or abnormality from the normal behavior of the element, then that is considered as the exception or anomaly. We are discussing the ionization energy, so it will be the group trend for ionization energy. I'll break down the term for you. Ionization, ions formation. And how an ion is formed? An ion is formed by the removal of electron. So the energy that will be required for the removal of the electron from the valence shell. Keep in mind that the outermost shell electron will be removed and the state of the element is in the gaseous phase. That energy is called as the ionization energy. Talking about the group trend. As we move down the group, the ionization energy decreases. Why is it so? Because the atomic radius is increasing, which means that the number of energy levels occupied by the electron increase. This increase in energy level also increase the distance between the nucleus and the valence electronic shell. As we know that the distance has increased, which means the attractive forces between the nucleus and the outermost electron has decreased. Atomic radius and ionization energy are inversely proportional. Since the attractive forces has decreased, now they have weaker attractive forces. So little amount or less energy will be required for the removal of the valence electron from the atom in the gaseous phase. Therefore, the group trend for ionization energy will be decreasing. But there are few exceptions that we have from the normal behavior. What does it mean? It means that the group trend should have decreased for the ionization energy, but here it is increasing. And why is it so? We have two exceptions in the P block in the group 3A and group 4A. For the group 3A, we have two more exceptions. The gallium has slightly higher ionization than aluminium. Also, thallium exhibits higher ionization energy than indium. If you watch carefully, so in both this scenario, the reason is same. And what is the reason? This is due to the poor shielding effect or the insufficient shielding of the nuclear charge. But for gallium, you have the d electrons. The d orbital is involved. And for thallium, the electrons of the f orbitals are involved. The reason is same, poor shielding effect or the insufficient shielding of the nuclear charge of the d orbitals for the gallium and f orbitals electrons for the thallium. Now the second exception for the p block that we have in the group 4a, that for tin and lead there is an irregularity observed. Why so? Because they both have nearly the same atomic radius. Because of this similar atomic radius, despite of the decrease in the ionization energy, there is no decrease. And what is the reason? The reason is that due to the lanthanide contraction, which means that the nucleus and the outermost electrons attraction becomes stronger, and this requires more energy for the removal of the electrons from the outermost shell. This is the reason that there is an irregularity observed between the tin and the lead. You can also prepare notes from this. I have made this video in complete note style, so you can write it down. There are a few questions that I'm going to ask and you can report it. I'm also going to write these in the description box so you can check that from there as well. How do you define group trend? Discuss the group trend of ionization energy. Gallium has slightly higher ionization energy than aluminium. There is an irregularity observed between tin and lead. Tin and lead have same atomic radius. Why? How do you define ionization energy? Write a short note on group trend of ionization energy. Why does ionization energy decreases as we move down the group? Mention the exceptions of ionization energy for the representative elements. So these are all the questions that you have for the ionization energy. You can also check the description box. The questions are mentioned there. If you still have any query, feel free to reach out and all the queries that you have regarding the topic will be answered. This is all for today. Make sure that you watch the videos completely so that you have a better understanding of the topic. Thank you so much.